Okay, we're going to look at something called the discriminant. Now, the discriminant is actually a part of the quadratic formula. So the quadratic formula is given by minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Now, the bit inside here, the b squared minus 4ac, that's called the discriminant. So let's get that down. D equals b squared minus 4ac. Okay, now, there's a few results that we want to consider here, which is when b squared minus 4ac is greater than 0, we call that the roots are real and distinct. Okay, now in class I'll explain what that means, but let's just take that, okay. Now, then we've got b squared minus 4ac is equal to 0, and that means that the roots are real and equal. And then we've got b squared minus 4ac is less than 0, and that means that the roots are non-real. Now, what does this language mean? Well, that's something that we'll cover in class. But let's just get into some of these. So what we're going to do is we're going to do something called state the nature of the roots. Okay, so we're going to state the nature of the roots. For the following examples, and let's start with example A. Example A is going to be 3x squared plus 5x plus 1 equals 0. Okay, now stating the nature of the roots is you find out whether the roots are real and distinct, whether they're real and equal, or whether they're non-real. Now, the first thing that we want to do is identify A, B and C. Now we did that with the quadratic formula. So A is 3, B is 5, and C is 1. Okay, so that's the first move. Okay, our next move is to write down b squared minus 4ac and start to sub things in. Okay, b squared, what's b? B is 5, so it's going to be 5 squared minus 4 times a, which is 3, times c, which is 1. Okay, 5 squared is 25, minus 4 times 3 times 1. Well, 4 times 3 is 12, and 12 times 1 is 12. 25 take away 12 is 13. Now, if you look back to the note there, it said that when b squared minus 4ac is greater than 0, so greater than 0, then the roots are real and distinct. Now we can see that b squared minus 4ac is equal to 13, so what we're going to say there is 13 is greater than 0, b squared minus 4ac is greater than 0, therefore roots are real and distinct. Because if we calculate that thing to be greater than 0, it means that the roots are real and distinct. So again, I'll go over what that means when we're in class. Those 3 circles there in a triangle shape, that means therefore. Okay, so that's what we're going to use for that. That means therefore. It's a quick way of writing it. Okay, so that's example A. Let's look at example B. Example B, we've got 5x squared plus x plus 2x, rather 5x squared plus 2x plus 4 equals 0. Okay, first move, identify A, B and C. A is 5, B is 2 and C is 4. Next move, it's going to be the discriminant. So b squared minus 4ac. So b squared, well, it's going to be 2 squared minus 4 times a, which is 5, times c, which is 4. Okay, 2 squared is 4, and then it's minus 4 times 5 times 4. 4 times 5 is 20, and 20 times 4 is 80. 4 minus 80 is minus 76. Minus 76 is less than 0. b squared minus 4ac is less than 0. Therefore, roots are, if you look back to the 3 definitions there, If it was less than 0, that means that the roots are non-real. Okay, so there's a quick summary up there. When the discriminant is greater than 0, roots are real and distinct. When it's equal to 0, real and equal. And less than 0, non-real. Okay, greater than 0, equal to 0, less than 0. Okay, let's try example C. We'll get 3x squared plus 4x plus 1 equals 0. First move, let's get A, B and C. A is 3, B is 4, C is 1. B squared minus 4AC. B squared, so that's 4 squared minus 4 times A, which is 3, times C, which is 1. 4 squared is 16, minus 4 times 3 is 12, 12 times 1 is 12, 16 take away 12 is 4. So what's 4? Well, 4 is greater than 0, which means the discriminant, that's what we've just found, is greater than 0, which means what? Therefore, roots are real and distinct. Okay, so that's called, when you make that decision as to whether they're real and distinct or real and equal or non-real, that's you finding the nature of the roots. Okay, example D, 5x squared minus 2x plus 3 equals 0. Okay, so A is 5, B is, be careful, it's not 2, it's minus 2, and C is 3. B squared minus 4AC, so it's B is minus 2, so it's minus 2 squared minus 4 times A, which is 5, times C, which is 3. You don't need a calculator for this. Minus 2 squared is minus 2 times minus 2, that's plus 4, minus 4 times 5 is 20, and 20 times 3 is 60. 4 minus 60 is minus 56. Minus 56 is less than 0. So that means that the discriminant is less than 0. Which means what? Therefore, the roots are non-real. Okay, example E. X squared plus 6x plus 9 equals 0. Okay, what's A? Well, what number's there? Even though you can't see it, it's definitely 1. B 6, C is 9, B squared minus 4AC. Okay, so B squared was B 6, so that's 6 squared minus 4 times A, which is 1, times C, which is 9. 6 squared is 36, minus 4 times 1 is 4, 4 times 9 is 36, 36 take away 36 is 0. So D equals 0, B squared minus 4 equals 0. What does that mean? Well, if you look back at the notes, the 3 statements, that means the roots are real and equal. Okay, example F. 4x squared minus 5x minus 3 equals 0. Okay, A is 4, B is minus 5, C is minus 3, B squared minus 4AC, was B is minus 5, so it's minus 5 squared minus 4 times A, which is 4, times C, which is minus 3, so I'm going to put that in a bracket. Okay, now if you put all that in your calculator, minus 5 squared is 25, and then minus 4 times 4 is minus 16, and then minus 16 times minus 3 is plus 48. Okay, put all that in and you'll get 73. 73 is greater than 0. B squared minus 4AC is greater than 0. Therefore, roots are, what is that again for greater than 0? Real and distinct. Okay, so it's really important that you try these 8, you need to practice these 8 before you come in tomorrow, because come in tomorrow we're just going to hit the ground running, and I'll do a quick example from the board and straight to it. Okay, so quickly have a go at these 8. calculate the discriminant each time. So each time identify A, B and C and then put it into B squared minus 4AC. If your result's greater than 0, that means the roots are real and distinct. If it's equal to 0, the roots are real and equal. And if it's less than 0, the roots are non-real.